Hello again. In this video, I'm going to go over this homework problem from 3.6. It says, suppose an object is fired vertically upward from the ground on Mars with an initial velocity of 102 feet per second. The height s in feet of the object above the ground after t seconds is given by s is equal to 102t minus 6t squared. And then part A says, determine the instantaneous velocity of the object at t is equal to 1. Okay, first of all, this equation right here, that is called a position function. And so the way it works is, you tell me the time in seconds, and I'll input that into this little formula, and then what comes out is the position of the object on a number line. Now this is one-dimensional motion, so we can think of the object as moving vertically. It only moves up and down in one dimension. And so it's probably good to think of this as being placed, this object is being placed on a number line that is oriented vertically. And so S tells you the position that the object is at on the number line for any given time t, and that's called a position function. So given the position function, we're supposed to determine the instantaneous velocity of the object right when t is equal to 1 second. Now, if I were to plug t equal 1 into the position function, I would get the position of the object when t is equal to 1. For instance, when I plug a 1 in here, I get 102 minus 6, which is 96. So at the 1 second mark, that means the object is at the 96 foot mark on the number line. In other words, 96 feet above the ground. But what we're supposed to determine is not the position of the object when t is equal to 1. We're supposed to find the instantaneous velocity of the object when t equals 1. Okay, but to find the velocity, we need the velocity function first. And if you're given a position function, you can find the velocity function by taking the derivative of it. Okay, so let's do that first. So here's the position function. If I take the derivative of this position function, that gives me the velocity function. So I'm going to label this as v of t. V for the velocity function. Okay, so the derivative, if you take the derivative of this with respect to time, you just get 102 minus 12t, because the 2 comes down and gets multiplied by the 6, and that gives you a 12. And then when you subtract 1 from this exponent, you're left with 1, so t to the first power. Okay, so that's your velocity function. Now this tells you the velocity of the object at any given time t, whereas the top one tells you the position of the object at any given time t. Okay, and we want to know the velocity when t is 1. So I'm just going to plug a 1 in for t. And you can see you get 102 minus 12, which is 90. Okay, and the units are going to be in feet per second. Okay, so that's part A. Okay, now part B. For part B, we're supposed to find when will the object have an instantaneous velocity of 12 feet per second? Okay, so if we go to the velocity function, we want to know when the velocity is equal to 12 feet per second. So I'm just going to plug, so here's the velocity function. Okay, and I want to know when the velocity is 12 feet per second. So when is v equal to 12, right? At what time do I get v equal to 12? So then I'm just going to solve for t here. Now to solve for t here, I'm going to subtract 102 from both sides, and that leaves me with minus 90 on the left. The 102 cancels out here because I'm subtracting it, and so I'm left with negative 12t. and then I divide both sides by -12, and that will give me my t. So, of course, the negative and the negative give you a plus, and so it's just 90 over 12, okay, which happens to be 7.5, and that's in seconds. Okay, so it takes at the when t is 7.5 seconds. When you plug that into the velocity function, you're going to get 12 feet per second out. That's how fast the object is moving when t is equal to 7.5 seconds. Okay, so now part C says, what is the height of the object at the highest point of its trajectory? Okay, so we need to know how high this object goes. What's the highest it takes on for height? Now, in other words, what is the largest value of s, which is the position of the object? Okay, so here's how we're going to do that. This object, again, is moving in one-dimensional motion. So again, we're describing this by thinking of it as being on a number line, right? The object is on a number line. 0 is the ground, and then the object goes up from there, and then at some point it stops. At some point it's going to stop and then come back down. And whatever position it is where it stops, this is the maximum height. Whatever position that is on the number line. And so what we're going to do is we're going to actually start with the velocity function and set it equal to 0, because we know that when the object reaches this highest point, it has to stop and then it comes back down. So the velocity is 0 when it's at its maximum height. And then once I have that, once I take this velocity function and set it equal to 0, I'm going to solve for the time. And then once I know the time, I can plug that into the position function to find out where it's located on the number line. Okay, so let's start with the velocity function. Again, v of t is 102 minus 12t, and we're trying to determine when the velocity is 0, so we set that equal to 0, and then we're going to solve for t. So you need to subtract 102 over to the left side, and then just divide by -12 on both sides. Okay, and so it's 102 divided by 12. Now let me see what that is on the calculator. So I'm just going to pull up the calculator and see. So 102 divided by 12 is 8.5. So 8.5 seconds. Okay, so that's the time it takes for it to get to this spot where it reaches its maximum height. And also that's at the point at which the velocity of the object is 0. Okay, so now I'm going to take the position function Now remember, this tells me the position of the object at any time, and I want to know where the object's located when t is equal to 8.5. So I'm just going to plug 8.5 in for that, for t here. And then solve for s. Okay, so again, I'm just going to plug this into the calculator. Now I'll show you a really nice way of doing this on the calculator. What you can do is go to your y = button, And you can actually enter in the original position function. So 102, and I'm just going to use x for my t. So 102x minus 6x squared, or 6t squared. 6x, and then you can square it using this button here. And then after you enter that in to your y equals button, then you want to go to this calculate button, which is a second feature button. So you got to press the second button and then calc. And then it gives you this menu here, and you want to select value, press enter. And then it's going to prompt you for the x value, and we want the x value to be 8.5. So if we put 8.5 into the function, notice I get an error here. And if you get an error, then it means you have to adjust your window. So I'm going to go to my window, and you have to make sure that your x min and your x max, that range there, contains the value that you're plugging in for x. So I need to make it's going from 0, that's okay, but I need to make it larger than 2. It needs to go at least to 9. So 8.5 is in here, is in this range. Also, you should check your y values. This is going from a y value of 0 to a really large number. You just need to make sure your output is going to land within that range as well, and I believe it will, but if not, we'll come back and fix that. So you may have to adjust your window for this to work, but go back to calculate. After you've adjusted your window, go back to calc, and then value, and then enter in the value that you are inputting. And you can see the y value does land in the range of y values that I had in the window. It's 433.5. Okay, so this is 433.5. And of course, this is in feet because the distance here, or the position, is measured in feet. Okay, and the time is measured in seconds. Okay. Okay, so that's part C. And then part D, with what speed does the object strike the ground? Okay, so this object goes up, it reaches a maximum height, it stops at that point, and then it starts coming back down, and then eventually it's going to strike the ground. So if we were to hit this with a radar gun right as it's hitting the ground, how fast would it be traveling? All right, what's its speed? Okay, so that's part D. Now, speed is the absolute value of the velocity. And the reason we take the absolute value is because when you have a velocity function like this, you can get positive and negative values for velocity. If a velocity is positive, it means it's moving in the positive direction on the number line. Whereas if you get a velocity that's negative, it means it's moving in the negative direction. So for example, here we got 90 feet per second for the velocity. That means it's moving upward towards the positive side at 90 feet per second. But then later on, this object is going to, so initially it goes up. At some point, it's traveling at the 1 second mark, it's traveling at 90 feet per second towards the positive direction. And then eventually it stops once it hits this maximum height. And then it's going to come back down. And as it comes back down, the velocity is negative. And we know it's negative because it's traveling in the negative direction on the number line. So your velocity can be both positive and negative. And the positive tells you that it's moving in the positive direction on the number line, whereas a negative sign indicates that it's moving in the negative direction on the number line. So velocity can be positive and negative. That just gives you, the plus and the minus just gives you the direction in which it's traveling. Speed is always positive. Speed is simply the magnitude at which you're traveling at. Okay, so what we're going to do is we're going to find the velocity of this object right when it hits the ground, which means the position of the object is at a position of 0. So s would be 0, right, when it hits the ground. And then we're going to find the time that it takes to hit the ground, plug that into the velocity function to find the velocity of the object, and then we'll take the absolute value of that to get the speed. Okay? So just make a note of that. Speed is the absolute value of velocity. Okay? And we want to know the velocity when it hits the ground. Okay, and again, that's when the position of the object is at s is equal to 0. And so what we're going to do is we're going to first find how long it takes for it to hit the ground by plugging 0 in to the position function. Okay, so let's find out when s is 0. Or maybe I should write it like this. Okay, so we're going to set s equal to 0 because that's the object's going to hit the ground. It's going to be in a position of s equal to 0. And then my position function is 102t minus 6t squared. Okay, and then we're going to solve for t here. Okay, so first thing I would do here, this is a quadratic equation. In this case, I think to solve it, you can try and factor it. And you can see you have common factors here. So you definitely have a t in common. And you certainly have a 2 in common. So I'm going to pull a 2t out. Okay, and then you're left with 51 minus 3t. And you can check that. 2 times 51 is 102. And then you're pulling this t out, so this t goes away. And you're pulling 1t out of here in front, so you're left with 1t. And then you're pulling a 2 out of the 6, which leaves you with a 3. And then you just want to solve this, so you get 2t is equal to 0. If you solve that, of course, t is 0. You just divide by 2. And then the other possibility is 51 minus 3t is equal to 0. And then I'm just going to add 3t over. And then divide by 3. So t is 51 over 3. Okay? And then this is the time that it takes for the object to hit the ground. Okay? In seconds. So this is in seconds. Now I'm going to take the velocity function, which again is 102 minus 12t, and then I'm going to plug this time into that to find the velocity at that time. So I'm going to evaluate this function at 51 over 3. Okay, and so I'm just going to do that on the calculator. Again, one way you can do this is to go to the y equals button and just plug in the function 102 minus 12t, in this case 12x, and then I'm going to clear out that square. Let me go back. It looks like this froze up. Let me try it again. Okay, so again, go to your y equals button. And then plug in the function 102 minus 12t, or 12x in this case. Okay, so that's your velocity function, and then you can go to calculate and then the value when x is 51 over 3. And then press enter. So I have to adjust my window. It's telling me that this input is not within the range of my x value, so I'm going to go to my window and then just make sure that's large enough. So I'm just going to go up to like 100 just to be sure. So 51 over 3 is between 0 and 100. All right, and then when I go back to calculate, the value when x is 51 over 3, it should work. Okay, so you can see you get negative 102. Okay, so that is the velocity function evaluated at 51 over 3, and that's in feet per second. Now again, the negative indicates that it's traveling in the negative direction on this number line, in other words, downward. And then the speed would be the absolute value of the velocity. Again, in feet per second. So it's actually 102 feet per second. So if you were to hit this with a radar gun right at the moment it's hitting the ground, when s is equal to 0, the radar gun would show 102 feet per second for its speed. Okay, so this problem has 4 different parts, but you can see how each of these parts are connected. In each of these parts, you're either using the position function or the velocity function, or maybe a combination of both to solve each of these problems. So you have to get comfortable with the relationship between the position and velocity function. Okay, the velocity function is the derivative of the position function, because the derivative gives you the instantaneous rate of change in the function that you're taking the derivative of. Okay, so like the position function tells you where the object is located at a certain time. The derivative of it tells you the rate at which the position is changing over time, and that's called velocity. Okay, so I hope you found this video helpful. I'll continue to work some more homework problems in Chapter 3, and hopefully you'll have a chance to look at some of those as well. Okay, bye-bye.